word for the word work. Okay, so function notation. First of all, we're going to change a slope-intercept. We've been working with slope-intercept. So this is in slope-intercept. Y equals y equals x plus 2. So, and we can even put in our slope. Since there is no coefficient, it's an implied 1. Now, we can also write that in function notation. We're going to change it to, instead of y, we're going to change it to the function of x. Now, let me explain the meaning behind this so it will make things a little bit easier. When we were first talking about x and y, x was the input. We also called it the domain. And y, after we substituted x in, would be our output. So now as we learn some new vocabulary and we learn about function, we're going to substitute or put in a value for x and find out what the work of that x will make or create as an output. So the symbol f of x, which replaced y, is read as f of x. It represents the value of the function, that's the f part, at x. That's what you're going to substitute in. For instance, if we were reading this right here, we would read it as the function of 3. What that means is, what will the work or the function, the output, be when x is 3? Let's go ahead and try some of these so it's not just a lot of words going on. Okay, so first of all, we're going to work with some function notation here. It says let f of x equal negative 3x plus 8. You should recognize that this looks very similar to slope-intercept. The x here is going to be our input, and the answer, or the function of that x, is going to be our output. So it says find f of x when the x is 5. So we're going to go ahead and we're going to put 5 in for x. So the function of 5 when, so here's what we're going to do with it, negative 3 times 5 plus 8. So the function or the work of 5 would be negative 15 plus 8, and that would equal negative 7. So f of x equals 7. We could also write that as y, or the output is negative 7. Okay, that means also we could write this as the coordinate point 5, negative 7. When we're inputting 5, we would, the output or the work of the work of 5 would become negative 7. Let's see what our next example. So our next example is going to be the same thing, negative 3x plus 8, but this time the function of x is when x is going to be negative 22. This time we're going to substitute negative 22 in for x, same as we did. So the function, because this is all together, this is saying what is the work of negative 22? Well, we substituted it in for x. So we have negative 3 times negative 22 plus 8. Now we're going to go ahead and we're going to simplify that. And I don't want to get you too confused. It looks like we have jumped ahead just a little bit here. Oh, I'm sorry. I see what we've done. There's a typo on here. 1 second. Let me move back here a little. Okay, so this time we're going to try to find x. It's telling me the function or the work of x resulted in negative 22. This should not be here. It should still be x. sorry, that was a misprint. So what we know is that the function is negative 22. So what we're going to write, I'm going to rewrite this one here because I've done some corrections. So the function, the results are negative 22. That's what this is telling me right here. We need to find x, it says. So I'm going to copy down negative 3 times x plus 8. Now, I've skipped some work here, or the example has. I'm going to go ahead and show you where that came from. We're going to get our constant terms. This is just regular algebra that you've been doing all year. Get our constant terms together. So negative 22 and negative 8 is going to be, the result is going to be negative 30. The typed one's a little bit easier, but you can see the action here. And then here, you can't see that, but my keyboard just showed up. Positive 8, negative 8 would give me nothing left there except for my variable. And my variable is going to be negative 3x. So you can see that in the typed version. Now I want to solve for a single x, so I'll divide both sides by negative 3. So I'll find out that my input to begin with should have been x equals 10. The result of it would be then that y would equal negative 22. So if I know that the function of x resulted in negative 22, then we went ahead and we solved for x to find out how did we get that result, and we found out that that equaled 10. Okay? Now we're going to work with some graphing of a function. Okay? The graphing of the function is going to be just the opposite of what we've been doing. So it says the function of x, or the result, or the output. I'm going to go ahead and add that to this screen here. The output, the work of x, equals 3/4 x. There's our input. My goodness. I have this typed in here. It would have looked a little bit better there. There, you can read that. The input would be 3/4 x plus 1. So the first thing, whenever I see the word graph, I need to put it in slope-intercept form. So I've gone ahead and just replaced the output, or the function of x, with the variable y again. Now we can graph it. We always start with the b, remember? I'll go ahead and I'll refresh your memory on slope-intercept form. You've had a lot of new vocab here. So y equals mx plus b. We wrote it in slope-intercept form because of the word graph. So b, the beginning, we always start with b, the beginning, begin with the b, is the y-intercept. So in this, we have the y-intercept is 1. That will give me a point to graph, 0, 1. Let me go ahead, I'm going to change, probably can't see that one very good. Now I'm going to look for my slope. My slope is going to be the coefficient to x, which in this case is 3/4. So m is 3/4. So that means when I get to my point 0, 1, I'm going to rise 3 and run 4, both positive. So let's go ahead. Hopefully I have a graph on this next screen. I do. So here I went ahead here, and for this screen, I rewrote what we wrote in, there we go, what we wrote in slope-intercept form because of the word graph again. I'm going to go ahead and graph the points. I'm going to begin with my y-intercept, which is 1. It's going to let me grab it. I'm going to have to do it on the laptop itself. So if it's the y-intercept's at 1, that means it would be at 0, 1. Whoops. Let me use 2 hands here. Put the iPad down. So my first step, I go to my slope-intercept form. I look at b, which is 1. That's my y-intercept, 0, 1. Now I'm going to apply my slope. My slope is 3/4. So from that point, I want to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. Okay? Now I'm going to, and I can go ahead, I went rise 3, and I ran 4. Now, hopefully I can use my iPad again. That would make it a little bit easier. I'm going to try to draw, for you, Tim. I'm going to try to draw. Let's do it in, we'll do it in yellow because black is my axes. So I'm going to go ahead and, all right, Tim, give me a break because it wasn't connecting very well. So I got it now. Draw my line there, and that's going to show me my function. Okay, my function of 3/4 x plus 1. That's going to show me all my inputs and outputs. All of the work of x, every one of the x's, is giving me a y. Okay? Now, one thing again to remember to check, we're going to go ahead and we're going to look at our equation. Our equation has a positive slope. We have a positive slope there. The last thing that you should remember always is to go ahead and, maybe not the last thing, but label your points. So this first point was 0, 1. And now remember, when you put in a slope, you're rising and then running. But when we go ahead and label a point, we go left to right first. So I'm at 1, 2, 3, 4. So for my x-axis, I'm at 4. And then after I did my rising, I was at 1, 2, 3, 4. So this other point is 4, 4. Now if we wanted to check those, we could go ahead and put those coordinate points in for x and y and see if they make true statements. And they do. Now example 3 is writing a function without a graph. So the last one we had a graph, so we were able to look at the graph. This time it says write a linear function of g. I am not sure why sometimes we change that. F, the italicized F makes sense because it is representing function. This is still representing function. It's an italicized G. So sometimes they even use H. So function G, given that G of 0 equals 9 and G of 3 equals -6. Now, remember, the function part is going to be the y, the output. And the what it equals is going to be the x. Okay? Oops, I wrote that backwards. Sorry. I was looking at, let me do my undo. Sorry. The function of x, that's our worker, is resulting in 9. So sorry. The function of 3, the work of 3, gives me the result of -6. Okay? So really, when it is written in this form, it's just giving you input and output in a different language, in a different form, and you're doing the same thing you've been doing throughout this chapter. So if we have to find the slope, we're going to look at them as coordinate points. So just as I labeled them, 0 is x, y is 9. Here's our first coordinate point here, and our second coordinate point is here. We're going to go ahead and find the difference between their y's and the difference between our x's. We end up with -15/3, which we can go ahead and we can reduce to -5/1. We can write that as just simply a -5 as well. So it says find the y-intercept b of the function's graph that the graph passes through 0, 9. Well, again, we know a y-intercept whenever we have an x is 0. That means we're not going to go left or right. So they're giving us that right here in the information. We had a point 0, 9, so we know that the y-intercept is 9. So what do we need to write it into a function form? we're going to keep it as the function of x. If we were going to graph it, that would be our y, equals our slope, which we figured out was -5. So we're filling in our slope, -5, and we're filling in our y-intercept, a +9. So just given information about functions, the work of 0, so the worker is x, results in 9, that's the output, that's y. Okay? This is the one that is the most easily mixed up, as I did, just not paying attention there, but as I did. So make sure if you have to review this again, maybe just start it at the point after I saw my mistake when I was actually reading what was in front of me. And again, I like to use the words the function of or the work of, and the input is the work, which is x, results, that's my equal, into the output, which is 9. Okay, let's go ahead and, do we have one more screen? We do. Do one more screen here. I have to pause for just a second. I'm having a little technical